Hello, my name is Tim Bollaslew, and I would like to welcome those of you watching to this interview with Robert Engle in the series of interviews with founding contributors to the academic field of finance sponsored by the American Finance Association. I'd also like to thank Dimensional Fund Advisors for making this all possible, for their generous support both financially and technically for doing this. Robert Engle shared the 2003 Nobel Prize with Clive Granger for the development of statistical methods for the analysis of economic time series. More specifically, Engle's Nobel citation reads, for methods of analyzing economic time series with time-varying volatility, parentheses, arcs. This work, along with Engle's many other contributions, including his work with Clive Granger on co-integration, has fundamentally changed the way that we teach and we practice the analysis of economic and financial time series. Engle is also generally viewed as one of the founding fathers, if not the founding father, of the now blossoming field of financial econometrics. So I'd like to begin this interview by asking Robert Engle what it's like to win the Nobel Prize. Now, the official prize ceremony takes place in Stockholm in a week, sort of in early December, surrounding December 10th, more specifically the day that Alfred Nobel died. And there's lots of very pompous sort of circumstances around that. But I was wondering if you could tell us a little bit about some of your sort of fondest or sort of special memories, maybe sort of from that week.
That week is a most incredible week. It's well, I like to say it's boot camp for scientists, because they take this group of motley academics with long hair and bushy eyebrows, and in 1 week they teach you how to eat with a knife and fork and talk to the king and queen and wear a tuxedo and talk to the media and become a spokesman for science. And really it's training. And there is this magnificent ceremony that many people have seen on TV or one thing or another. But in addition, there are lunches and dinners at the embassy. The U.S. Embassy hosted the American laureates. The British Embassy hosted the British. The Economics Committee had a dinner. The King and Queen have a little private dinner for a mere 100 people in their castle. And then there's the students put on this amazing, it's an amazing week.
Yeah, you started out in the PhD program in physics at Cornell, at Cornell as I understand it. So why physics and why Cornell?
Well, I think I must have been a little ambivalent about it, because in the fall of my senior year at Williams, my advisor said, well, are you going to apply to graduate school or not? I said, oh, is that now? And eventually, in kind of a last-minute way, I did apply, and I got into both Cornell and Berkeley, and I was trying to decide what to do about those. So when I got to Cornell, I immersed myself in this program, but it was in the basement of the physics building, and I was doing low-temperature physics with liquid helium and superconductors and things like that. And I realized that I didn't really want to spend my life doing things that only 10 people in the world could understand. And so I went over and talked to the economics department. I'd had lots of friends who were had switched from physics to economics, but I'd only had one economics class, so I wasn't really sure whether this would be possible. So I just made an appointment with the chairman of the department, whose name is Fred Kahn, who is a wonderful man, and I am close to even today. And I just asked him, well, Fred, has anybody ever done this? Would it be possible to make the switch, and what would, if so, how would it happen? And so he said that this is a good day to ask this question, because we have just been turned down for a graduate fellowship, and if we give it back to the university, we don't get it. Do you want it? Well, you know, it's one of these moments in your life when your past races by and you're thinking, what am I going to do? Right. Yes or no? Right. So I said yes. Right. And that was the moment.
Now, going back to your graduate studies in economics at Cornell, who was your thesis advisor at Cornell, and what was your thesis about?
my thesis advisor was T.C. Liu Dazhong, and he was an amazing man. He had a force of will that made things happen. He moved mountains. He had built a macro model of the U.S. economy, which was an annual model in the late 40s, and in the 60s, one of the big races, like the moon race, was who could build a quarterly model. And the Brookings Institution had this enormous collection of people all commissioned to write an investment equation or a consumption equation or an inventory equation. And Dazhong decided he would do it himself. Right. And he actually finished his model well ahead of the Brookings Institution. And so he had estimated both the quarterly and an annual model of the U.S. economy and was interested in higher and higher frequency data because he thought that the simultaneity problems would be much better in high frequency data. So he was actually in the process of working on a monthly model where he had to interpolate and infer a lot of the data. So the thesis topic he suggested to me was time aggregation. What's the difference between building a model on monthly frequency and annual frequency or whatever? So I did actually some sort of complicated econometrics on that, which led to not very general results, I'm afraid, on what is the effect of time aggregation in this case. And these were in the nature of, let's suppose the monthly model is really right. What would you expect to see for the annual model? But it got me interested in spectral analysis and time series in a much more important way. And actually, macroeconomics was a natural thing for me to be looking at.
Right. Your first academic job was at MIT. How did that come about? How did you land a job at MIT?
I'm not sure.
Okay.
It was a funny year in the job market because they canceled the annual meetings because of the riots in Chicago in the Democratic nomination for president. Right. And so there was an alternative market set up, the so-called gray market in Philadelphia, which was basically just a job market. Mm-hmm. And so I talked with various schools there, and Dazhong, I think, must have written some pretty supportive letters. But after it was all over, I had offers from both Yale and MIT, and as well as various other places. Right. And so I think they must not have understood exactly what I was doing, but could see that I was, I was a little bit of an unknown quantity with a lot of math and some interesting ideas, and might actually learn some economics and do okay in the profession.
Right. Well, what are some of your other sort of more exciting work, sort of in your own mind, from your MIT days?
Well, I did a lot of urban economics when I was at MIT. These were the days when it was thought that big models were going of cities would help us shape the cities, figure out where to put roads and how to deal with center city decay and all these kinds of problems. You may remember Solow wrote this paper on the long, narrow city. So people were doing optimal growth and optimal transportation. So the idea was, well, what about econometrics? Can't we do something good with econometrics, not just theory? Right. So Frank Fisher and Jerry Rothenberg and John Harris and I had a grant from the Ford Foundation to build an econometric model of the city of Boston, which turned out not to be that easy.
Surprise.
So we made some interesting inroads in this, and some of the ideas, like the linked price indices for property values and so forth, are being used by lots of people today. But it was not that easy to build an econometric model of a city that would answer some of these questions.
Well, it's an interest that stayed with you for a long time, right? I mean, I remember from San Diego, you continued to sort of dabble a little bit in urban economics.
That's right. And I taught urban economics for many years in San Diego, and I did periodically write another paper or two, and I had a variety of thesis students who wrote urban theses. I still think it has some of the same characteristics that I see in financial econometrics. It's got massive data sets without good models that people have actually estimated. So I actually think it's a pretty fruitful field for somebody to work in.
Okay, so let's move on. After 6 years at MIT, you moved on to San Diego, UC San Diego, the economics department there. I understand it was Clive Granger that recruited you to San Diego. Can you tell us a little bit about how you first met Clive and how he was managed to convince you to come to San Diego?
We were both, well, the first time I met him actually was in my first big meeting, which was the World Congress in Cambridge, England. And Clive had organized a session on new ideas in time series, where he had put my paper on time aggregation, as well as a paper by Chris Sims and I think Phoebus Drimes, maybe, I'm not sure. And so Clive was quite pleased with having set the session up, and so that's first when I met him. But then Arnold Zellner had a series of conferences on seasonal adjustment, and both Clive and I were on his steering committee. So we would see each other at a couple meetings for each of these conferences. And in one of them, when I was thinking about leaving MIT and looking around at different places, I asked whether San Diego ever had any interest. And he said he'd check, because they're hiring a lot of people. In fact, they weren't hiring in econometrics. Because, well, they had Clive and they had John Hooper and some other people. So he said, I don't know whether we could do this or not, but why don't you come out and give a talk? And I said, well, I could talk about urban economics. Oh, yeah, we need an urban economist. So I was hired in San Diego as an urban economist. And but the reason I went was obviously because Clive was there, and I could see that it was going to nourish my interest in time series in a way that would be very good for my career.
So I'd like to move on and talk a little bit about the arts model, or maybe not just a little bit. So talking about arts, maybe you can just sort of, for people that aren't necessarily familiar with what the model looks like, try to give an intuitive feel. What is an arts model, and also along the way, maybe tell us, what does the acronym ARTS actually mean?
Right. What the acronym stands for is a little bit scary, but it stands for autoregressive conditional heteroscedasticity. And I do have my classes practice saying that, because it's not that easy to say. But once you've got it, ARCH works fine. And what the ARCH model does is it predicts what I like to say it predicts risk. It looks at data and tries to figure out what kind of risky outcomes might we expect in the short-term future. It does this in a very simple way. It says when the market is volatile today, that is, price moves are large and unpredictable in both directions, then it's likely to be volatile tomorrow. But that this eventually goes away. And when it's quiet today, it's likely to be quiet tomorrow, but eventually will become more volatile again. And so it's a very simple model, but by the time we've managed to figure out a way of estimating this simple model, then there is no limit to the more complicated models that you can look at in the same sort of vein. And as we were saying, one of the real goals in ARCH modeling is to figure out what economic variables would be useful in predicting volatility.
Right. I understand that the basic idea behind the arts model came about during a sabbatical that you spent at London School of Economics. Can you tell us a little bit more about sort of the basic idea behind the model and how that all sort of came about?
I was at the London School of Economics on leave in 78. Okay. Oh goodness.
And nice when you're having fun.
Maybe it was 79. 79, sorry. And I had sort of this list of things that I was interested in, but one of them was a conjecture that Milton Friedman had made, which is that business cycles were caused, at least in part, by the volatility or the unpredictability of future prices. That is, the uncertainty in inflation. Right. So that businessmen would be risk averse and they might not invest in as many projects if it wasn't so clear what the prices they could get for them or what the cost of labor would be and that sort of thing. So it wasn't that inflation itself led to business cycles, it was the uncertainty of inflation. And when you think about it, there's kind of no way to use our econometric tools to answer that, because the variance of inflation would simply be a sample statistic that you calculate. Mm-hmm. So I was trying to think about whether there was an econometric tool that we could develop to try to answer this question.
Right.
And being a time series person, it was natural to think about updating. Each time you get a new observation, how do you update your estimate of the variance? And eventually I was able to realize that we can consider the variance at each point in time as an estimate. We can estimate the future variance conditional on the information we have today, and build a very nice model that looks like that.
So the paper on the arts model was published in Econometrics. Was that a hard sell? Do you remember some of the comments, criticism from the referees and editors on that?
Yeah, it was a little bit of a hard sell. I think they felt like the referees thought that this was a pretty narrow little thing, and why would anybody really be interested in this anyway? It's, you know, it's one of these criticisms from the referee, which you get fairly often, which is, you know, the paper is right, but it's uninteresting.
Right.
So I tried to make it more interesting and enrich the introduction and put some stuff in it on macro forecasting and stuff like that. And eventually said, okay, we'll take it.
Now, sort of narrowly kind of defined in the arts area, are there still sort of big, important research questions in arts? And if so, what are they?
Yeah. Well, one that I've recently written about is sort of the long-run predictability of volatility, and whether it's got any relation to the macroeconomy. And if you think it's all news, is there anything which predicts when we're going to have a lot of news? And so I was actually quite encouraged to find that when you look at macroeconomic data, when economies show more variability in their macroeconomy, they tend to have more volatile financial markets. So that might be a time when you'd expect to see a lot of news. Similarly, when the inflation is higher, you find that the volatility of the financial markets is higher, because I think you're probably getting a lot more news per unit time in a high inflation environment than a low inflation environment, and a variety of things like that. So I think that the connection between economic variables and the volatility has really been difficult to establish.
So kind of looking back, I mean, your move into finance, was it mainly the application of the arts model, you think, that sort of drove that, or was there something else sort of that really fascinated you about finance?
You know, I think the arts model was really the reason I did it, but I think there are other things about finance that fascinate me. You know, I said at the beginning that I liked making these tools, or for science project or something like that. I think that's what I do professionally too. I like creating models that do something that somebody needs to have done.
Right.
And you know, the ARCH model is a very simple model that forecasts volatility. I have models that forecast correlation. I have models that are designed to minimize price impact when you're trading, looking at risk-return trade-offs in high-frequency trading problems. I have models that talk about when is the next event going to happen in a tick-by-tick kind of basis. So I think that I really like the data, I like the problems, and there is such richness to the finance environment that it's very stimulating.
Right. Now, since moving to New York University, you've started the new Center for Financial Econometrics. Could you tell us a little bit about what you hope to accomplish with that center? What's the goal?
Well, this center is designed to have both academic research and practitioner interaction, but it's especially interdisciplinary because we have statisticians in the Stern School, we have econometricians in the arts and sciences, and the finance faculty, all whom are interested in closely related topics. So we have a seminar series. I now have a postdoc, and we've had visitor positions for a couple of years. The idea is that this is actually a center for doing cutting-edge financial econometrics, which will be of value to the practitioner community as well as the academic community.
Right. I was wondering if you could talk a little bit about sort of how you first became interested in market microstructure. I guess it was sort of back in the mid-90s when that sort of all happened. Mm-hmm. And what sort of drove those interests? Was it data or what else?
You know, if I think about my thesis advisor, Da-Chung Liu, going from annual data to quarterly data to monthly data, I've done most of my volatility work on daily data.
Right.
And so the question is, what's the next step after you do daily data? And obviously market microstructure is the next step. Right. When you want to see what's happening to asset prices on a higher frequency basis, there's all this information that you're ignoring when you just use one observation a day.
Right.
So I guess it might have been the Olshan conferences that really initially stimulated my interest in market microstructure. Right. They had a couple of conferences in Zurich on high frequency data analysis and made some data sets available which were very interesting. People did a lot of work with those data sets. I think they actually moved the profession in that direction.
Right. Do you have any thoughts on what, I know you're still very much engaged and working in that area. What are some of the sort of key issues that you are struggling with in market microstructure these days? Well,
I did this this paper with Jeff Russell on predicting when the next trade was going to be and that sort of thing. So this is a very high frequency point process model. And one of the comments that I got, which I thought was such a good comment, was, what you're trying to predict is the least interesting thing in finance. I thought to myself, whoa, is that right? And then I try to say, why is it interesting to know when the next trade is going to come? Well, because you want to know what's the volume of trade. And why do you want to know what the volume of trade is? Well, that has something to do with the liquidity of markets. Right. So I got more and more interested in market liquidity. And how do you measure it? How do you measure price impact? How do you do all this thing? And then when someone would ask me the question, I'd say, the reason we want to know about market liquidity is we want to know how to trade. Right. So when Morgan Stanley came to me and said, we're building an algorithm to try to trade, I said, that's for me. So we've spent a lot of time developing algorithms for how to take advantage of changes in market liquidity, and there is a natural trade-off here between waiting till the market is more liquid, which takes some time and means the prices might move while you're waiting, or taking this bad price that you would get when the market is illiquid. And so there's a risk-return trade-off in the middle of this trading engine, which turns out can be linked back to portfolio models and multivariate models and the whole thing. So that's been, I think it's time-varying liquidity that has interested me the most in this microstructure.
So I guess that sort of gets to something also I'd like to talk about, sort of the process of writing an Engle paper. Sort of what comes first, the data, the theory, or what's sort of the interface between the two?
I tend to think that there are three legs to a stool, to a research stool. One is the data, one is the theoretical idea, and the third one is the econometrics. And I think that any one of those three can initiate a project. Sometimes I've got the method first and I'm looking for an application. Sometimes I have the data first and I'm trying to figure out how to look at it. And sometimes I've got the question first.
Right.
And you know, I don't think they have to be equally important, but I like to keep all three of them in mind every time I'm doing something. And I think the Arch paper, the way we talked about it, was kind of like that. Yeah. You know, the data has to look like this, otherwise it's not going to go anywhere. And the problem has to be a good problem, otherwise it's not going to go anywhere.
Talking about good problem, is there sort of one particular problem that has stuck with you for a long time that you wish you had solved, that you never sort of really had the time to solve, that you're still sort of in the back of your mind, puzzling over?
Yeah, kind of. There is actually. It's got a couple of different flavors to it, but you might say it's high frequency correlation. How do you measure correlations on a tick-by-tick basis? Or another way of saying
what does it mean? I mean, when things don't trade, what is a correlation?
That's right. Mean? What does it mean when things don't trade? And they trade, you know, one asset may trade very frequently, another one infrequently. How do you look at the correlation between those two assets? And I think a related question is, can you tell which one moves first? We have now data on when the trades happen and the prices at which they happen. Somehow you should be able to come up with a price discovery model that says, well, in this market this one moves first and the other one moves. But most of the methods are sort of biased towards saying that whatever trades most frequently has the most information in it. And but I don't think that's necessarily the right answer.
So sort of looking ahead, I mean, the field of financial econometrics, which I think, as I said at the beginning, I think you arguably sort of is the founding father of, if not at least one of them, clearly. Where do you think that field is going to be sort of 10 years from now? I think we had like a glorious run over the past 10 years.
You know, we have, but I don't think it's going to end. You know, I think people are a little bored with volatility models, but really there are plenty of other things that are interesting, and there's a lot of interest in extreme moves, in extreme correlations, in asymmetric models which have, you know, special downside implications, and I'm doing a lot of work now on skewness, which I think is interesting both from possibly portfolio point of view, but more importantly maybe from options point of view when you see implied skews and stuff like that. And as Wall Street and all markets around the world become more computerized, they're moving faster and faster. They need more models. Models are doing the trading. Maybe models are picking portfolios. And one of the questions which I suppose we all wonder about, what's the limit as these computers get faster and faster? You know, and does financial econometrics have anything to say about that?
Just a race to the moon?
Is it a race to the moon? Are we going to see a cusp where prices go to zero or infinity, or are we going to see very smooth asset prices?
Okay.
Okay, great.